Welcome to David Alexander Maths Tuition. This is chapter 9b on differentiating exponentials and logarithms. Okay, so if y is e to the x, what is dy by dx? Well, hopefully from your year 12 studies you know that e to the x is its own derivative. So if y is e to the x, then dy by dx is e to the x. What about if y is e to the 2x? Well, hopefully you know that dy by dx is 2e to the 2x. So if y is e to the 7x, then dy by dx is 7e to the 7x. Now, in year 12, you're probably simply thinking that the derivative is just the function, but you just put the number, in this case 7 at the front, or 2 at the front. So here we're going to just put 1/2 at the front. And I suppose that's fine, but actually what are we doing here? Let me just explain one in a bit more detail. So what if, say, y is, let's do a ridiculous one, e to the power of 23x, then dy by dx is e to the 23x multiplied by the derivative of the power here. Now the derivative of 23x is 23. So that is why we're getting this number 23 at the front in this particular example, and that's because we're taking the derivative of 23x. Don't see it as we're just simply moving this number to the front, because as we'll see in a moment, when we get some more complicated e functions, then we do need to remember that we're multiplying the function by the derivative of the power. Okay, so here are some other examples. So if y is 4e to the 3x, then dy by dx is going to be 4e to the 3x multiplied by the derivative of 3x, so times 3, and we can tidy this up. That becomes 12e to the power of 3x. If y is 16e to the 7x, then dy by dx is going to be 16e to the 7x multiplied by 7, and now we can clean it up by multiplying together the 16 and the 7 to give me 112e to the power of 7x. Okay, so here are some other examples where we've got a number in front of the function. So if if y is 4e to the power of 3x, then dy by dx, that is going to be 4e to the 3x multiplied by the derivative of 3x, which is 3, and of course 4 times 3 is 12, so that is 12e to the power of 3x. Let's have a look at the next one. So dy by dx is going to be 16e to the power of 7x multiplied by the derivative of 7x, which is 7, and 16 times 7 is 112, so that's 112e to the power of 7x. Let's look at this last example, a bit more complicated. So dy by dx is simply 6e to the power of 3x squared multiplied by the derivative of 3x squared, so that's going to be 6x, and we could tidy that up. That could be 36x e to the power of 3x squared. So that is the derivative. So just remember that you copy the function and then you're differentiating the power link associated with the e. Okay, so here are some more complicated examples where we've got e to the power of a trigonometric function. So dy by dx, that is going to be e to the power of cos x multiplied by the derivative of cos x. Now cos differentiates to minus sine, so it's minus sine x, and a nice way to write this would be minus sine x e to the power of cos x. Okay, if y is 16e to the power of sine x plus cos x, then dy by dx is 16e to the power of sine x plus cos x multiplied by the derivative of sine x plus cos x, which is cos x minus sine x. Here's another example, again pretty horrible function. So the derivative is 6e to the power of 5x squared plus cos 5x multiplied by the derivative of 5x squared plus cos 5x, so 5x squared becomes 10x and cos of 5x becomes minus 5 sine 5x. Okay, this last example's a tricky one, but we're only differentiating a trig function here. Now we know that cos goes to negative sine, so dy by dx is the negative sine of e to the power of 3x plus 7, multiplied by the derivative of the stuff in the brackets. So what is the derivative of e to the power of 3x plus 7? Well, that is going to be e to the power of 3x plus 7. So here we're now differentiating. We've done the trig, now we're differentiating an e function. So we're going to copy the function and then multiply that by the derivative of the power of the e function, so times 3. So we could write this as negative 3 e to the power of 3x plus 7 sine e to the power of 3x plus 7. So with a question like this, you just need to sort of do it in stages. So just think, how do you differentiate a trig function? Well, you do cos goes to negative sine of this stuff here, multiplied by the derivative of this stuff. But because there's an e function in the stuff, we need to be careful about, well, what do we do here? And remember, when we're differentiating an e function, we copy the function down and then multiply it by the derivative of the power. Hope that makes sense. Okay, now we are differentiating some exponentials. So with experience, this is the one that students often find the hardest to remember. Now, if y is 3 to the power of x, then dy by dx it's the natural log of this number here. So it's going to be ln 3 multiplied by 3 to the power of x. Nice and easy. Although it's not quite as simple as that. Well, it is as simple as that. We also need to multiply by the derivative of the power. Now here it's an x, so that will differentiate to 1, so times 1. So a lot of the time we can just ignore that bit there when it's just 3 to the power of x. So if y is 5 to the power of x, then dy by dx is going to be the natural log of 5, so ln 5 multiplied by 5 to the power of x. If y is 7 to the power of x, then dy by dx is ln 7 multiplied by 7 to the power of x. If y is a third to the power of x, then dy by dx is the ln of 1/3 multiplied by 1/3 to the power of x. Okay, now sometimes it can seem a bit more confusing when there's a number in front of it, but just think, what is 3 to the power of x when you differentiate it? Well, dy by dx would be ln 3 multiplied by 3 to the power of x, but it's just 4 lots of that, so it's just 4 times ln 3, or just 4 ln 3 times 3 to the power of x. So if y is 2 multiplied by 5 to the power of x, then dy by dx is 2 ln 5 multiplied by 5 to the power of x. And if y is a third times 7 to the power of x, then dy by dx is 1/3 multiplied by the ln of 7 multiplied by 7 to the power of x. So you can see it's not really that complicated, but it's just one of those ones that's very easy to forget, and it's the sort of thing you're likely to forget half a dozen times between now and, well, when you're watching this in your exams, but just as long as it's in your brain when you sit your exam, then you'll be fine. Okay, so here are a final few examples. So just remember that when I said a moment ago that if y is 5 to the power of x, then dy by dx is ln 5 multiplied by 5 to the power of x. But I also did say in the first example, it's multiplied by the derivative of the power, and the derivative of x is 1. Now, of course, if I'm multiplying all this by 1, then, well, it's just ln 5 times 5 to the x. But here's an example where it's 3 to the power of 7x, so dy by dx is going to be ln 3 multiplied by 3 to the power of 7x multiplied by the derivative of 7x, which is 7. So therefore dy by dx is 7 ln 3 multiplied by 3 to the power of 7x. Okay, so do remember that we do need to take the derivative of the power as well. So if we've got y is 5 to the power of 4x, then dy by dx is going to be ln 5 multiplied by 5 to the power of 4x multiplied by the derivative of 4x, which is 4. So I'll just chuck the 4 at the front. 4 ln 5 times 5 to the 4x. If y is 7 to the power of 0.5x, then dy by dx is going to be ln 7 multiplied by 7 to the power of 0.5x multiplied by the derivative of 0.5, so, well, just 1/2, so a half ln 7 times 7 to the power of 1/2x. Okay, let's take a look now at how to differentiate a ln function. So what you just need to remember is that when you're differentiating ln, it's going to turn into a fraction. If we refer to this as the stuff, on the top is the derivative of the stuff, and on the bottom is the stuff. So on the bottom will just be the x. And what is the derivative of x? Well, it's just 1, so that becomes 1 over x. Let's do a few more examples. So y equals the ln of 3x, so the stuff is the 3x, so dy by dx is the derivative of the stuff, so the derivative of 3x is 3, over the stuff, which is 3x, and again that will just cancel down again to 1 over x. The ln of 7x is exactly the same thing, so x, so the stuff is 7x, so what is the derivative of 7x? It's 7. What is the stuff? It's 7x. And again, that will differentiate to, well, that will simplify rather to 1 over x. Actually, the ln of any number of x will always go to 1 over x. But just remember, differentiate the stuff divided by the stuff. So here's some more, slightly more complicated examples. So the stuff is x squared, so the numerator is the derivative of this stuff, so that's 2x, and the denominator is the stuff, so x squared, so 2x over x squared. So that will become 2 over x. Let's look at another example. If we've got the ln of 6x to the power of 4, then dy by dx is on the top is the derivative of 6x to the power of 4, so that is 24x cubed, and on the bottom we've got 6x to the power of 4, and again that can be simplified to 4 over x. Okay, here's the ln of a trig function. So remember, differentiate the stuff over the stuff, so the denominator is always dead easy, that's just cos x. What's the derivative of cos x? Well, that is negative sine x. And well, what is sine over cos? Sine over cos is tan, so minus sine over cos is just minus tan, so we can tidy this up further. The derivative of the ln of cos x is negative tan x. Okay, so to finish off with, here is a tricky example. We want to find the equation of the tangent, so therefore we are going to need to do some differentiation. So dy by dx is going to be e to the power of 2x times by 2, so 2e to the 2x, subtract e to the minus 3x times minus 3, and of course minus 3 multiplied by that minus sign will be a plus 3e to the minus 3x. Now we know x is ln 3, so when x is ln 3, then dy by dx is going to be 2e to the 2 ln 3 plus 3 lots of e to the minus 3 ln 3. Now we need to remember that e and the ln can cancel out, but not when there's a number between them. So what we need to remember is, well, what can we do with this number 2 and this number minus 3? Well, we can move that up to be a power. So that can be 2e to the ln of 3 squared plus 3e to the ln 3 to the negative 3. And now the e and the ln can cancel out. So that's 2 times 3 squared. 3 squared is 9. 2 9s are 18. 3 to the negative 3 is 1 over 3 cubed, 1 over 27. So 3 over 27, which is 1 over 9. So therefore, the gradient is 18 and 1/9, or just in terms of ninths, I'm going to say that is 163 over 9. Now I also need to work out the coordinate. So when x is ln 3, y is e to the power of 2 times ln 3, take away e to the power of minus 3 ln 3, so that is e to the power of ln 3 squared minus e to the power of ln 3 to the minus 3, which is 3 squared minus 3 to the negative 3, so 9 take away 1 over 27, so therefore the y coordinate is 242 over 27. Okay, so now for the equation of the line, it's going to be y minus the y value, so y take away 242 over 27 equals the gradient 163 over 9, lots of x, take away the x value, which is ln 3. We're going to leave this as it is. So what I'm going to do now is just add this fraction here to both sides. So y is 163 over 9, lots of x, take away ln 3, plus 242 over 27, and I am going to, because I'm looking for a number in front of the y, I'm just going to multiply through by 27, so I'm going to get 27y equals 163 over 9 times 27, which is the same as 163 multiplied by 3, and that is 489 x minus ln 3 plus 242. So A is 27, B is 489, and the C is 242. So pretty horrible example there, but a few learning points. A couple of things about making sure that we can cancel an e and a ln, but provided we've got rid of this number first, which can become a power. So these are the sort of things that do crop up in some of those tricky questions in an A-level paper.